Hey everyone, and welcome to this explainer on behalf of Forge College. So if you've been following along with our track on transitioning from EVM to SVN, basically moving your developer mindset from Ethereum over to Solana, you know we've been deep in the trenches of advanced account patterns. In our previous lesson, we tackled the security edge cases for account abstraction. We measured attack surfaces, set up monotonic nonces, and even built a revocation registry to just completely shut down forged replays and stale session reuse. But today we're taking a massive step forward. We're moving out of the lab with those isolated security experiments and going into full assembly. We're talking about preparing for the Capstone and integrating all these advanced patterns into a clean, testable, fully functional artifact. Let's get into it.
Because let's be real for a second. What happens when you hand off undocumented, untested code? We've all felt that universal developer dread, right? It's Friday afternoon, you hand over a scattered pile of session key scripts, and by Monday morning, the Capstone team is literally hunting you down with pitchforks. A bunch of isolated scripts and half-baked experiments? That's not a working machine. To make sure the next team can actually pick up your work and run with it without a million ambiguous questions, we really need to get organized.
And to do that, we have a super clear engineering blueprint for today. We'll start with the handoff blueprint, move into assembling the code skeleton, and then we'll hit stress testing the machine. From there, we'll talk about writing the manual, run through the final quality check, and finally ensure you are 100% ready for Capstone. All right, Section 1, the handoff blueprint. Let's define our project increment and figure out exactly what it is we're handing off. Our whole goal today revolves around this idea of a project increment. Now, this isn't just a zipped folder with some random code shoved inside. No way. It is a cohesive, testable assembly of wallet flows, verifier mocks, and crystal clear documentation. It is totally ready for Capstone intake. Essentially, we're taking all those isolated design decisions you made, how session keys are passed, how they're verified, the expected test fixtures, and reconciling them into one single, undeniable source of truth. Moving right along to Section 2, assembling the code skeleton. Let's map out the physical parts of our machine, starting with how the repository is structured. Think of this layout as your architectural floor plan. It shows exactly where every crucial piece of code lives. You've got your scripts folder, which holds walletflow.js. That's the demo script actually running the wallet to session key flow. Then, your verifier folder holds the program mock validating your nonces and revocations. You've got your automated tests, a handoff.md for checklists, and a readme.md for quick starts. Locking down a predictable structure like this is hands down the best way to prevent integration regressions. The next team shouldn't have to play detective to find where your code starts. And right in the middle of that structure, the verifier mock acts as the engine of our skeleton. And this engine, it expects a very specific type of fuel. The API demands a strict JSON blob containing the principal, the session key, the nonce, the validUntil timestamp, and the payload. It's a deterministic gatekeeper. It enforces the rules we established last time and spits out explicit error codes. If that JSON blob isn't absolutely perfect, it fails, deterministically. Zero guesswork allowed. Section 3, stress testing the machine. Let's talk automated tests. If the verifier mock is our engine, we need to put it inside a wind tunnel for some rigorous, predictable trials. And when we run those trials, we absolutely have to avoid the bane of every developer's existence, the flaky test. You know the ones. Actually, we've all suffered through them. They rely on real network time, they suffer from random intermittent failures, and they literally only pass on Tuesdays when the stars are perfectly aligned. We don't want those. We are pushing hard for fast, deterministic testing, tests that are predictable, use seeded inputs, and execute in milliseconds without calling out to any external networks. So to prove your delegated flows are structurally sound under attack, your deterministic suite needs to cover 3 mandatory scenarios. First, the happy path. An increasing nonce succeeds, which just proves the system works when everyone plays nice. Second, replay blocked. Resubmitting that same nonce fails outright, proving your replay protection holds up against attackers. And third, revocation fails. A revoked key gets firmly rejected by the registry. If your local validator can run these 3 and pass them reliably, your machine is solid. All right, Section 4, writing the manual. Yep, we're talking about documentation. Look, you wouldn't ship a complex piece of heavy machinery without a user manual, right? Thinking your code is self-documenting is a classic developer trap. This is where you hand over the keys to the car. Your docs need to be totally unambiguous. You got to define the exact JSON shapes expected for signed operations. You need a migration.md file listing every single required environment variable and how the verifier maps to a real deployment. Throw in a quick table of exact error codes. Oh, and absolutely crucial here, exclude all your environment-specific secrets from the repository. Just supply a sample.env file instead, please. And here is a massive pro tip that will literally make you a hero to the Capstone team. Leave them a debug report. Something simple, like a debug/replayfailure.txt file. It's just a plain text log capturing a failed test, but you annotate it with the exact steps you took to fix it. Saving this debug history is like leaving breadcrumbs. It preserves your institutional knowledge and stops the next team from banging their heads against the wall repeating the exact same edge cases you already solved. Section 5, the final quality check. Okay, the machine is built, tested, and the manual is written. Now we hit the climax of the whole process, local validation. This local checkpoint run proves everything works together seamlessly. And here is the golden rule for any handoff. The Capstone team must be able to execute this entire flow within 15 minutes of checking out your code. Step 1, they run npm run dev start to boot up the local verifier mock. Step 2, they run node scripts/walletflow.js, and bam, it should yield verification OK right in the terminal. Step 3, they run npm run dev test, and those 3 deterministic tests we just talked about pass instantly with 0 flakiness. If this sequence breaks, you iterate locally until it works. And finally, Section 6, ready for Capstone. Once that local validation sequence runs cleanly, you've made it to the successful handoff. So, let's summarize the core principles here. To drastically reduce friction at the Capstone intake, remember these 3 things. 1, make those interface contracts explicit so nobody is guessing about JSON shapes. 2, prioritize deterministic tests for reliable, instant reproduction. And 3, always include concise operational notes and your debug artifacts. I want to leave you with this sort of technical proverb because it really captures the difference between a decent developer and a great engineering partner. The most valuable handoffs contain not only working code, but the troubleshooting history that led to it. Context is just as important as the logic itself. So I'll leave you with a provocative question to chew on before your Capstone orientation. Is your final codebase a well-oiled machine or just a pile of parts waiting to break? If you follow the blueprint we just laid out, I'm confident yours is going to be the well-oiled machine. To dive deeper into these concepts, master more Web3 engineering patterns, and explore the rest of our EVM to SVM track, make sure you head over and visit our website at forge.college. Thank you so much for hanging out with me in this explainer on behalf of Forge College, and I'll catch you in the next one.